Good morning, everyone. We will start in a little while. I'll just let you all enjoy this peaceful Friday morning music to make sure that you don't end your week in stress. We'll give the remaining few that registered some time to join in. All right, welcome. Good morning, everyone. It's 1 minute past 11 on a Friday morning, and Morten and myself will have a 30-minute session on designing for meeting rooms. And we thought we'd take a little bit of a different approach, right, Morten? Yeah. Audio and video together instead of fighting for the last remaining kroner on the budget. We thought we'd talk about things that we can do together to come to a better end result. So the idea is to talk about meeting rooms and how audio, video, a little bit lighting because you can't forget them, but they're not in the meeting, but it's part, all can come together to enhance the actual experience. Because I think when we first started talking about this, Morten, one of the things that you mentioned is, and now you have to remind me the extra number, what is it, how many was it?
Yeah, 60-bit information intake. That's what we as a human being can process. So 60 bit per second. And
60 bit per second, okay.
Yeah. Being spoken to is 40 bits, so then you have an idea on what we can take in.
Yeah. So just put that in comparison to the data stream that goes through an HDMI cable, which is 18 gigabits per second. It's quite amazing that with the limited processing power that we apparently as humans have, that we can actually make sense of the world. But it also immediately shows that we can't start overloading people with information because it just doesn't work anymore. So I think that's one of the things that will be that was sort of the starting point of this session. As you may know, I work for Panasonic as a sales engineer, and Morten, you work for Fohhn
Audio, yes.
Yeah.
Also as sales, technical support, and a lot of design support of speaker systems.
Yeah. So in the support, just to mention that we have a lot of design tools available. I can't mention every single one out here. We have on Panasonic side things like throw distance calculators. We calculate three-dimensional designs, and I saw that Fohhn also actually has a quite sophisticated looking tool that people can make use of. Correct?
That's correct. We have a 3D design tool which is made so that it's fairly intuitive as much as you can in those kind of tools, but pretty easy to get around.
Yeah. I imagine that if someone is not a audio wizard, you'll be there to help them out.
Definitely.
Good. Let me start by talking about, I think, the first thing that most people worry about, their starting point is the screen size of a screen in the room. Now, this is something that we could already talk about more than half an hour, so I'm just bluntly racing through some things here that can give you a little bit of a grasp. Of course, the most important thing is, what are you going to do in the room? How big is the room? And how many people are going to be sitting there to take out as a starting point? There are some rules of thumbs, like half the size of the room is the screen diagonal, and then easiest to measure that in inches because diagonals are done in inches, or screen height is the distance to the last viewer divided by 6, etc. So all of they give a little bit of a starting point, but it's not the one thing that is definitely 100%. Because it really depends on whether you're going on resolution 4K or not, if you're going to do video or Excel sheets, etc. And the same then, the next question is indeed 4K or not. Yes, for your projector, your screen, that really helps. Pixels get really smaller, but think about whether you really need to have the signal at 4K, because Windows desktop generally immediately start to scale down to a lower DPI, which can cause all kinds of unforeseen problems, etc. So there are really some things to think about when you're looking at screen size. Next on that list I want to talk about is contrast ratio. And I'm going to be a little bit arrogant, so excuse me. Feel free to later on tell me that I was blatantly wrong. But a lot has been said about contrast ratio. Avixa Infocom has written really big studies on it. They're really good. They absolutely did their utmost best to give you all the science behind it. The only thing I think that they forgot is to take the actual room into consideration. So they have been looking at the contrast ratio on the screen, which is correct. That's where the content is. But what we're trying to do today here is take it a little bit broader than just that one little thing, not just my screen or not just Morten's speakers. There is much more going on in a room. And the effect of the wall color and the average overall room light levels, or the light level on your desk, are not really involved in their calculations. And I just wanted to show you something that's from a completely different area, framing of pictures and paintings, etc. So they already knew a long time ago that it made a big difference how you frame stuff. What do you put on the side of it that will make it appear completely different? And we can demonstrate that quite quickly. I hope that I'm certain that this will come across. We have here a very lovely gray line, and it's gray all over, no differences. And as soon as I do this, we start to see completely different things happening. The right side will appear much darker, the left side pretty white. It is still the same bar. The same goes for here, A and B. There isn't a person in the world that will say that A and B absolutely look the same. Of course, if you've seen this, you say, like, yeah, well, I know that they're the same, because as soon as you do this, they are the same. But it goes to show that it makes such a world of difference what is happening on the outside of your screen. And the outside of a projection screen, or the outside of a LED wall or a flat panel display, is the wall that it's mounted on. So when really fancy high-end rooms are designed with modern-looking metal and glass, etc., we end up in a scenario where projection and any kind of image transmission is severely impacted by what we see around us. And it makes such a big difference if we just do something simple like that, make the wall a bit darker around it. Simple trick, huge effect. So something to keep in mind before you go into a room and just accept what a customer has given you, to maybe explain, like, oh, this might not really work the way you wanted it, or if this is what you want, you might have to think about a different technique, think about a larger screen, or even a smaller screen, depending on what the situation is. So those brightness levels in the room are quite important, and they are not easy to work with. These numbers here come from Google Meet. The light level on the face should be about 400 lux, and it should be twice as bright as the background. 400 lux is quite a lot. We rather not see that anywhere near projection screens, because it means that with those Avixa numbers in mind, 7 times the contrast ratio, or even 15 times for critical decision making, or basic decision making. That means that 400 lux, that would be really big projectors. 200 lux is about the max that we like to see. But if you think of the earlier room that I showed where windows are in play, you will never get to 400 lux being twice as much as the background of the person sitting there. So thinking about the light levels in relation to the projector or the LED screen or the display, it's quite important to keep the balance not just on the side of the room where you're doing it. It has to be throughout the entire room. Because otherwise we end up in situations like this, where the screen has a very nice bright image, but it's completely out of balance with the room. This is a room where people will fall asleep for sure. The other way, with lovely natural daylight, etc. I think these are extreme pictures, so everyone can recognize what's going wrong here. Imagine sitting across from the people that sit in front of the window. You will not be able to see them. They'll be in silhouette. And what's happening on the screen, I think that's quite clear for everyone to see, that's not helping anyone. And even if this was a extremely bright high-end LED wall, you'd still get a line across the screen. So thinking about these things and explaining this to your customer is quite important step in order to guarantee that you end up with a room where everyone is satisfied. So when you've got that under control and you've decided what you're going to do, you have probably chosen your products, and then it becomes that this should be there is no Morten, there is no sense of order here. This should go hand in hand. Not saying that at all, but anyway, a lot of our products have fans in them, and that of course is the projectors that we supply, but there is also equipment that ends up in a little cabinet in the corner of the room, etc. Fans are necessary. Electronics heat up, they need to be cooled. Fans work quite simple, even though the science behind them is incredibly different, but the effect quite simple. The more air, the more cooling. The only thing that we don't want is increase the fan speed. When we increase the fan speed, we start to get noise, and that's what we'd rather not want. So the solution would be having more fans or larger fans. That means that things might grow bigger. But here are two 7,000 lumen projectors. And Morten, I think you'll be able to explain the difference between 32 and 38 dB.
Sure can. If you look at it there, you have a 6 dB different. It doesn't seem that much, but if we consider that a 3 dB increase results in a doubling of the energy. So the sound energy will double per 3 dB. So now you have 6 dB increase. So first we double, and then we double again. So it's 4 times the energy. That's not what we perceive, because that takes 10 dB to perceive a doubling, but still I like to always consider the actual energy of the sound. So it's a lot. It's a logarithmic scale, so slight increase means a lot.
Yeah. And I don't know, do you have any comparisons? There are the dBs are always so out in the air. 32 dB, 38 dB. Is there anything that we can compare it to?
I'd say 38 dB is still way lower than when we speak, or the normal background noise. So we're still fine here in relation to background. We need to get a lot higher before we exceed.
Yeah. No, that's good. I think my Swedish sales guy that's also joined in this meeting will be very glad that you didn't bash the little projector on the top that we sell a lot of. But just to give you an idea that there are things that you can do to make a huge difference. And yes, of course, the smaller one on the top is probably cheaper. I don't do prices, but I can imagine that smaller and bigger, they have some price relationship. If you want to stay with smaller and still want to make a difference, you can also do this. When you're looking for a 5000 lumen projector and you really want to drop the decibels, running a 7000 lumen projector in quiet mode actually is way quieter than running a 5000 lumen at full speed. So in a 7000 lumen, we have a lot more laser diodes available to make the 7000 lumens. Of course, you need more, you put in more. But if we don't run them at max, then that means we don't need to cool at the top of our capabilities, and we can drop from 36 dB down to 28 dB. And I think 28 dB is already getting close to the sound of breathing, if I'm not mistaken. Yeah. So it will just be like adding another silent partner in the meeting that's just sitting in the corner breathing away slowly. So these things are possible. I fully understand that this is also has an impact on anyone's budget, but I think that if you think smartly, you can do this while at the same time reducing the screen size slightly. For example, just give some numbers. If you put the top one on the 155 inch and the 5000 lumen, and if you put the 71 on a 137 inch, they are equally bright. Yes, you've lost some inches, but you've also lost in this case 8 dB, which is close to a doubling and a doubling and a doubling. So then we're at 8 times the energy.
Yes.
So
okay.
That makes, well, I'm starting to get a hang of this sound. So there are quite a few things to do that can really help out. So I think from my side, these 3 things are the ones that I think that are in no way an exhaustive list or everything that you need to do, or if you just follow these 3 things, you do great. But these are really good starting points. So that is the screen size, the contrast ratio, and the brightness in the room, and then the noise level and the way you deal with that on the units. So with that said, I'm gonna let you do some more, and I think you take over. Great.
Thank you very much, Felix. And as a lot of you maybe already sense here, Felix and I found that there are some similarities between sound and the visuals here, how we are affected. So, for example, framing does a lot to how we perceive things, and I'll try to get a little bit into that. I could talk for hours about these things, but I need to speed up. So I think I'll have a different approach than speaking about speakers and technical stuff and so on, because what I find often is that maybe we're not lacking the knowledge on what sound is, but quite many needs a slight reminder. So I would like to start by pointing out that while sound is invisible, it challenges us from time to time, especially when we're talking about fighting over a budget. It can be pretty difficult because you can't see it and you can't touch it. So explaining it is rather difficult. So first and foremost, I think it's important to say sound is very, very physical. It is air molecules under pressure and then a release and pressure, release, pressure, release. The faster it goes, the higher the frequency. The slower, the lower the frequency. So it's a physical impact, and sound is something that impacts you every single day of your life, every hour, also when you're asleep, because you do not have earlids. So you're always affected by sound. It's the first sense that awakens when we're born. So it's the first thing we will discover, that sound. And guess what? When we have to leave this earth, it's the last thing that turns off. So it's always present, and it's something we need to take very seriously, and unfortunately that's not always the case, especially talking budgets. That one I always hear, or quite often, and let me just point out very short and precise, it's not correct. We are very good at listening, and we do hear the difference, and we do that in multiple aspects, and I will just get into a few examples later on that part. I'll also state that sound is very fundamental for us. I said it's important, it's always around us. And if we consider our 5 lower senses, it is by far the primary for us. Sound is what we react to the quickest. So if we're alerted by sound, we react faster to that than on anything else. And the lower senses is, of course, we have our hearing, we have our sight, and then we have the smell, the taste, and feeling, so if we are touched. And it is so, we were talking a little bit about how much information we can take in. The 60 bits, if we exceed that, or at least in general, when we receive information, whether it's sight or auditive, we affect the other senses also. So they affect each other. Actually, if I exposed all of you to pink noise now and you were eating, you would find that you taste less salt, less sugar, but more umami. So there's actual research behind that part. So it affects each other, and it's actually quite simple if you think about it. Regarding the sensitivity and bandwidth, we already were into it a little bit here with the 60 bits per second. And I can actually serve a very good example of that. Let's see if it starts. Yeah, you'll find that this is rather annoying. So I'm speaking and you're hearing Judi Dench or the nice woman M talking, and you'll feel your brain is like circling around. And if I could see your eyes, they'll be spinning more or less now. So it's really, really annoying. And that's one effect of when we are being overloaded. Of course, this part also, when you are thinking about doing offices, you need to think about what noises are in there. We were already into it on the fans, and yes, Felix, we are way lower than normal speech, because there we are talking 60 to 70 decibels if you raise the voice, 65, 75, and up to 85 if it's really loud. So for your projectors, no worries, you can easily put in with 38. Of course, the lower, the better. So in a business perspective, what do all of these things mean if we don't take it seriously? Yeah, with the noise, I can tell you, if you are in a really noisy environment, for example, open plan office, there's research indicating that productivity can be reduced up to 2/3. So imagine having 20 people in there with productivity reduced by 2/3. You need to take it seriously. Yeah. So it's expensive, rather expensive, and not just because of productivity loss, but also because of health issues. It's unhealthy. So it's something we always should think about. One thing I also would like to consider when we're talking about these offices, I'm often met with this thing, it's just for presentations. And yes, that's the main thing, especially when we're talking hybrid meetings and so on. The presentation, the voice is very, very important. But I would like to use music here, first of all, as an example. When we react to something like this, and you probably felt it when you entered this meeting, it's nice and you relax. Multiple things are happening inside your head and your body, actually. When you hear something you like and you react to it in a good way, maybe even with the goosebumps, it's dopamine release in your brain. So it's a hormone thing that's going on. That's because, as I said before, we are good listeners and we can actually foresee what's happening in the music. Even though you're not conscious about it, you will foresee, and your brain will also always try to foresee what's happening. And when you are right, or even better, if you're surprised in the music, that's where we get the goosebumps. So that's basically just dopamine. Another thing is that if we are gathered around music, especially if we're singing, there's another hormone going in play here. That's oxytocin. And oxytocin is what makes us feel or create unity, a feeling of unity. So we bind because of oxytocin. Example on where oxytocin for us as human beings are fundamental. It's a hormone that's partly designed, we guess, in research, to help ensure the survival of our species. So a newborn baby, and the mother gets the baby to the chest, and you think this beautiful little newborn baby. The fact is that the little newborn baby is often not that beautiful. They can be rather ugly, to be honest, but we need a binding. So what happens once that baby is put to the chest is a massive release of oxytocin, and there you have a really, really strong binding happening. So to a business perspective, unity and binding, I guess that is something we do like in a company, especially when dealing with a lot of employees. So you could take advantage of using music in these things in the meeting rooms. And for that matter, there's on the technical term, I'll be really quick about this, as I haven't spoken much about it. And let me just simply, now not to disturb, shift to a blank thing here, so we don't exceed our 60 bits per second. Keep it simple when considering speakers. You can consider point source speakers, line source speakers, beam steering speakers. I would say the most fundamental thing is to ensure that you have something that is frequency-wise full range. You need to have the lower end. One, to have a voice come out as natural. Pay attention to the speech direction. So what you're looking at, and that's where your audio should come from. I know that we cannot get around ceiling speakers, but try to get a little bit around it. It's not pleasant to have someone speaking from the ceiling and down to your head. And even though you're not conscious about it, you are putting your brain on overload. Maybe not overload, but it needs excessive processing to do that. So try to maintain the correct speech directivity.
Just one quick question, and Morten, on this directional. How does that rhyme with voice lifting systems? That's apparently, from what they are, not directional because they are lifting it throughout the entire room.
Exactly. In voice lifting, we are playing around with more things. So we have, of course, it's often coming from the ceiling actually, but with voice lift, we try to keep it so low you don't pay attention to any speakers. You shouldn't recognize that they're speakers unless we turn them off. So that's the first thing. The other thing we are playing around with is delay times or latency. And there you put something called the Haas effect in play. So I can give you a good example on how it works. So in church, for example, now let's take a meeting room and you have a presenter in the right corner. If I delay the left speaker, so it has a delay compared to the right speaker where we have the presenter, you will perceive it. The audio will arrive at your ears at a later point than the right speaker. And automatically your brain will think that's further away, and by default that would be lower. So you perceive it as lower even though it's exactly the same level coming out of the speakers. So now you shifted the kind of audio perception to the right. So that's also a little bit what's happening in the voice system. The full range part, just to finalize, that's important for the speech, of course, but also in relation to music. And you will, in your keynotes, your presentations, meet professionally done presentations that has music and so on. And it's important that we play it back to get the full effect of it. And as I said, we can foresee what's happening in the music. If you know just a little bit about music, you will quickly realize that if we can foresee how tonality progresses, how chord moves around in the music, what is the most defining thing in music for chord progressions or tonality progress? That's the bass line. That is the fundamental. If you miss that, your brain will search for it. So you're not only losing the positive effect or some of it from the music, you are also putting your brain at work because it will try to foresee what's happening in the music. Whether you think you're good at listening to music or not, it happens.
think we should make a quote out of that to please all the bass players out in the world. That the world doesn't turn for money or anything, but it turns for the bass line.
Oh yeah.
Yeah.
Careful, I'm a drummer.
Yeah. Okay.
Yeah.
Good.
You can take
Thank
control.
you very much. Yeah, I'll do that. And thank you that we could do this together. That was really nice. For those of us that have joined us and would like to tell me whether I should do this again or not, or have any other comments or critiques or requests, please let us know. You can just quickly scan the QR code. I know we get bombarded every single time you drive through a McDonald's or whatever. Could you please rate our service? I know, but this time it's me asking. Yeah, it's not just a random company that is out there to make money, because I mean, oh shit, I work for a company that makes money. Never mind. I'll leave it at that. And I wish everyone a really good weekend, and I hope to meet you all soon again. And please ask further questions either now or the next time we meet. And then I wish everyone a good weekend. Thank you very much, Morten, and we'll speak soon.
Thanks a lot, Felix. Thank you for the opportunity, and thanks everyone for joining.
Thank you very much.